So good evening, everybody. Tonight we're going to continue our discussion on risk and uncertainty, but with particular emphasis on decision tree and simulation, with emphasis on decision tree and simulation. So when we talk about decision tree, what we are actually referring to is a pictorial representation of series of interrelated decisions and outcome. So in a question, you can be given alternative course of action, alternative decisions that you can make. But for you to arrive at a particular decision for an organization, or that will be suitable for you as a person, you need to do some analysis. And for you to solve decision tree question, you'll be given probability, you'll be given possible outcome. So in decision tree, we represent each of these possibilities using a diagram. We use a diagram, a tree-like diagram, to evaluate decisions involving risk and uncertainty. And this tree-like diagram will show available alternatives. This tree-like diagram will show possible future events. This tree-like diagram will show probabilities. This tree-like diagram will show outcomes, or what we refer to as payoffs. The payoffs can be in form of profits, can be in form of revenue, it can be in form of prizes. Yes, so it depends. So why decision tree? Decision tree helps an organization, helps an individual to choose the best decision using expected value. And in our first class, we define expected value as what? Summation P in relation to X, where P is your probability and X is your possible outcome. So when we talk about decision tree, there are 2 points we must note. There's what we call decision node and chance node. Decision node and chance node. Another word for decision node can be choice points. Another word for chance node can be uncertainty. So when we talk about decision node, this node is used where there are no probability attached. That is, you use decision node to depict a point whereby there is no probability attached to that point. So with decision node is a point where you are certain of the actual decision you want to make. So the decision node is a node that is used where there is no probability. Where there is no probability to a given cash flow, where there is no probability to a given outcome, you use decision point. And decision node is represented as what? Is represented with a square. See it here, with a square. Now, the other is the chance node. Or we can refer to the chance node as what? The point of uncertainty. So the chance node is the cycle or oval shape. It has associated probability attached to it. You can see in the case of decision point here, whereby you are planning to make a decision, either to proceed with a project or to scrap the project. So you are faced with two possible decisions here. But what will determine your decision here will be your expected value in the long run. It means in decision tree, you solve forward, then you solve backward. You draw your tree forward, but for you to make your decision, you have to walk backward. You have to walk backward. So the chance node is a node that has associated probability. It is denoted either by a cycle or by an oval shape. And it is the point where we have probability associated with a cash flow or with certain possible outcome, a certain possible outcome. So when we talk about decision tree, you want to make a decision either to go to Lagos or to go to Kano. What will determine your decision if you are to go to Lagos or to Kano will be what? Will be the benefit associated with each of these two locations. By the time you plot your possible chances of going to Lagos and you put your plans in place, and you discover that in going to Lagos every month you make 500,000 based on certain circumstances that you've put into consideration. In going to Kano, you make 300,000 in a month. Now, these are your expected values. So for you to make a decision either to go to Kano or to Lagos will be a function of your expected value. So it is these two outcomes, the highest of these two outcomes will determine the decision you are going to make. So, but in making your decision, you start with a decision point, which is the square. Now, what are the two options you have? To go to Kano, to go to Lagos. You draw. Yes, in going to Kano, what are you going to do? You put another option. Yes, that is the chances. In going to Lagos, what are you going to do? What are the available jobs there waiting for you? You put these options. Now, based on these jobs available in relation to this location, which will give you the best satisfaction? Sometimes jobs might not be in relation to the financial implication. It might be based on the satisfaction that you get from it. Yes, you can get a lucrative job and you don't have peace of mind. In the office can be something else. So there are certain factors we put into consideration. So now your decision will be based on the possible outcome, on the expected outcome. Yes. So, but based on what you're seeing on the screen, note that when you have to make a decision, you start with this square. The decision point will be the first thing you have to draw when trying to come up with a decision tree. Then the decision tree will have, it can have 3 options. You can have 4 alternatives. Yes, but in this case, we have proceed, we have scrap. You are faced with a decision to proceed or to scrap a venture. So what will determine your decision will be the expected value. If you proceed and the outcome is greater than the outcome of you scrapping it, it means you have to proceed. But if the outcome of scrap is greater than proceeding, it means you have to scrap. For those that have watched the video I forwarded on the platform, the YouTube link I forwarded on the platform, where I discuss the question on Mr. Smith, where we have to show the decision tree. You would have seen what played out in that video. where we solve forward, then we now solve backward. Yes. So in decision tree, you draw your tree forward, but in making your decision, you walk backward. You walk backward. Now, what are the steps required to solve questions involving decision tree? What are the steps required? Number one, you can write in your book. You can write in your book. Number one step involved is you draw and label the decision tree. You draw and label the decision tree. You draw and label the decision tree. That is the number one step for you to come up with a decision tree. When you draw and label the decision tree, what else will you do? You determine the terminal values, that is the ending values. The ending values through a forward pass. There's what we call forward pass. You drawing the decision tree forward is a forward pass. You following the decision tree backward is a backward pass. So you determine the terminal values through a forward pass. We're going to see that when we present an example. Then, once you determine that, you determine the value of the internal knots through a backward pass. The first, once you plot or you draw your tree, you move forward. As you move forward, for you to come to a conclusion, you solve backward. You solve backward. Now, as you solve backward, for you to make a decision, you determine the highest payoff for each decision knot. The highest payoff for each decision knot. So the expected value for a chance knot will always be determined by what? Probability multiplied by possible outcome, or probability multiplied by cash flow. So these are some of the steps you must note. Now, please take note of this. You are seeing on the screen. Let's move forward. Let's look at this scenario. This scenario as it regards decision tree. That a company. I'm with you, sir.
Okay, I'm sorry to interject, sir. So now, please, could you please restate the fourth step, sir? The fourth step.
Okay, I said determine the value of the internal knot through backward pass. For you to determine the value of the internal knot using backward pass, you can determine the internal knot through backward pass using the highest payoff for each decision knot. The highest payoff for each decision knot. Okay. Then I said you can use expected value for a chance knot. And expected value is what? How do we get our expected value?
Is the profit times the profit times the probability.
Yes, probability multiplied by profit, probability multiplied by cash flow, whichever the question is referring to. Yeah, so we have this scenario here that a company is considering whether to invest in a new project costing 12,000 naira, which has an 80% chance of being successfully developed. So what is the percentage of this project not being developed?
20%.
20%. The question will not tell you. The examiner will not tell you. The examiner will not tell you. So since it is stated that the percentage of it being developed successfully is 80%, automatically the percentage of it not being developed successfully will be what? will be 20%.
20%.
Will be 20%. But for you to develop this project, how much will you invest? How much will you invest? 12,000.
12,000.
12,000. If it is developed successfully, if the project is developed successfully, the profit from the project will depend on whether the economic conditions are good or poor. So the profit expected depends on the economic condition, which are forecast as follows. The economic condition can either be good or poor. Now, for this scenario to take place, for you to experience this, it means you will have to develop the business, right? You have to
Yes.
develop. If you
Yes.
don't develop, this circumstance will not set in. This scenario will not come if you don't develop. So you have two options, either to develop or not to what? Develop.
Develop.
Now, when you develop, you have another two occurrences.
Options.
Yes. When you develop, what are those two occurrences that is likely to set in when you develop?
Either it's successful or it's unsuccessful.
Yes. When you develop, is either the business is successful or not successful. Or not successful. Now, when it is successful, what is the associated probability? When it is successful, what is the associated probability?
60%.
30%.
80%. Fine. And when it is not successful, the probability is what?
20.
20%.
Fine. Now, when the business is successful, what are those two possible outcomes again?
The economy is strong.
Good or
Good
poor.
and poor. Yes, good and poor. When it is successful, you can either be faced with two economic conditions, good and poor. And when you are faced with a good economic condition, what will be your profit or loss?
50,000.
50,000. And the associated probability with a good economic condition is what?
60%. 0.6.
60%. And still, when you develop the business, the other conditions, economic condition that can befall your business is a poor situation. And when you are faced with a poor economic condition, you experience a loss of how much?
20,000.
20,000. And the associated probability is what?
0.4. 40%.
0.4. So all this we are doing can be represented in a decision tree. Yes. Then once you represent in a decision tree, for you to come up with a decision, you solve backward. You solve backward. The condition with the highest expected value will inform your decision. Will inform your decision. Now, if you look at this, the first step is to come up with our decision point, which is A. When we plan to invest, to develop a business, it can either be to develop or not to develop. If you do not develop, you won't put in any capital. It will remain like that. But when you develop, you will have to give out how much? 12,000.
12,000.
Now, when you develop, this will lead to other chances. Will lead to the chance node. And what will be the chance node? You can see when you develop successful and what?
Poor.
Unsuccessful. When you develop, it can either be successful or what? Unsuccessful. with the associated probability. Now, when it is successful, you are faced with two conditions again. What are those two conditions? Can
Good
you
and
see?
poor.
Good and poor. When it is good, you have a profit of 50,000. When it is poor, you have a loss of what?
20,000.
20,000.
40,000.
Now, for you to make a decision, what will you do?
You
What will
walk
you do?
backward.
You walk backward. You walk forward, now you walk backward. Now, when you're walking backward, how will your solution be? The associated probability with the good condition is what?
50,000 times
0.6.
50%.
0.6.
0.6.
Fine. So 60 multiplied by 0.6, and that will give you what?
30,000.
30,000.
Fine. Then 0.4 multiplied by 20,000 loss, that will give us what?
8,000 lost.
To give us 8,000,
Lost.
to give us 8,000 loss. 8,000 loss. Fine. So when you do plus and minus at point C, what will be your decision?
22,000.
22,000.
22,000. 22,000. At that point, that will be the results. 22,000. Now, the next thing, when it is successful, the probability is what?
0.8.
0.8.
When it is successful, it is 0.8. It is 0.8. Now, what will happen in this regard? What will happen? What will happen? 0.8 multiplied by the outcome of the difference between 0.6 multiplied by 50 and 0.4 multiplied by 20,000 will give you what? That is 22,000, right?
Yes, sir.
Yes, sir.
Yes, 22,000. So 0.8 multiplied by 22,000 will give you what?
17,600.
17,600. Now, 0.2 is not having any outcome. So 0.2 multiplied by 0 will give you what?
0.
So the addition of 17,600 plus 0 will give you what?
17,600.
17,600.
Now, 17,600 will be our outcome. Will be our outcome when we invest 12,000 naira to develop that business. And when we do not invest, the outcome is what? Is 0, because you are not
0.
giving out. Now, the question we have to ask ourselves, is it beneficial to invest 12,000 and get 17,600?
Yes, sir.
Yes, sir, because we'll have 5,600.
So we have a profit of 5,600. So you can see, for you to come up with a decision, you have to walk forward. Then when you walk forward, then you can now walk backward to determine your decision. To determine your decision. Let's take this example, another example, to explain this further. Okay, what we've said, these are the results. These are the results. In case you are not writing, this is the analysis. So let's take down this question and see how we can draw up a decision tree.
Sir, please can you go back? Sir, please can you go back to this to the last slide so that I can screenshot? Yeah. Okay. Snap now. Oops.
We can have this example. We can have alternatives. Alternatives. We can have a growing economic condition. We can have declining economic condition. And the alternative, we can have, let's say we want to invest, we can have our shares, and the share is growing. It's growing at 80, this declining at -10, and we can have commercial paper, situation where it is going 63. These we can have -8. We can have this. We can have bonds, and it is growing 20, and this can have it as 20. And have this as 20. As 20. Then the probability when it is growing 0.4, it is declining 0.6. 0.6. Now, looking at this table, you are faced with 3 options. You want to make a decision, either to invest in shares, commercial paper, bonds. What do you think we are going to do? I want to get some reactions. How do you think we can go about this? You want to make a decision, either to invest in share, commercial paper, or bond. What will inform your decision? Yes, this is a practical issue. Decision tree is a practical something. That is why I will have to engage you. Yes, so that
Okay, so for me, it will be the ROI.
okay, that is return on investment. Yes, but before we come to that point, what are we going to do? Can you just how will the diagram look like? Should, in case you want to.
Okay. Buy shares or do not buy shares. The decision node will be buy shares, then do not buy shares at opposite sides.
Okay.
Okay, so I think that each of the decisions will be drawn differently.
Very well. Yes.
Okay, can I try, sir?
Yes, sir.
Okay, we can have two options, whether to invest or not to invest. Then if you are investing, which of these are we going to invest? I think that would be the next this thing. But the question is whether to invest or not to invest first.
Okay. Okay. All right. So in this question, you have the options, 3 options. You need to make a decision on which of these investments will be profitable to you as an investor. But the case is this: when you invest in share, the share will grow at what? At 80. While there can be a decline of what? -10. When you invest in commercial paper, a decline of -6, bonds 20, either in a growing state or in a declining state, the result is 20. Now, the probabilities when any of this is growing is what? 0.4. Probability of declining is what? 0.6. So for you to draw a decision tree, your decision node will have 3 points, isn't it?
Yes,
3
sir.
points of shares, of commercial paper,
And
and of what? Of bond. Isn't it? Your shares will lead to chance node. The chance node of your shares will be growing or what? Declining. Isn't it? Growing or declining. Also, your commercial paper will have a chance node with 2 points, growing or declining. Then your bonds is also expected to have 2 points, but because the outcomes are same, the results are same, there's no need for us to have 2 points. We can just come up with a point because the conditions, either growing or declining, is giving us same outcome. Same outcome. Even when you solve with your probability, you still get 20. You still get 20. So there's no need to come up with 2 points. You can just have just a single point. But should in case you are not too sure, you can still come up with 2 points, growing and declining. And when you solve backward, you discover your result will still be 20. Your result will still be 20. That is cumulative for both growing and declining. Now, when it is growing for shares, what will be your associated probability when it is growing?
0.4. 0.4.
0.4. Fine. I'll forward my decision tree. I was trying to use my system to make it more beautiful, but I was not having much time to use graphics to present the decision tree, because what I will show on the screen might not be that clear. So let me send it to the group so that you see how it looks like. So this is what I've put forth. Hope you can see.
Yes, sir, we can see.
So looking at using that question, interpret this decision tree as I try to forward using the question. follow up the
So for
question.
shares, okay. So let me try. I don't know.
No, I'm just saying, look at
Okay.
it on your own. Interpret it to yourself.
Okay, sir.
So looking at this decision tree, you see that for you to make a decision, you need to draw up the 3 points of alternatives, which is shares, commercial paper, and bonds. But what will inform your decision? When you solve backward, 0.4 multiplied by 80 will give you what? Zero 0.4 multiplied by 80. That is the associated
32.
probability. Now 0.6 multiplied by 10
6.
will give you 6.
It's
So
6.
32 minus 6 will give you what?
26.
So for shares, your expected outcome is what? Is 26. 26%. For commercial paper, when you solve backward, what will be the outcome? For commercial paper, when you solve backward,
You see.
for commercial paper, when you solve backward, that is 0.6 multiplied by, or 0.4 multiplied by 63 to give you what? Then 0.6 multiplied by
25.2.
25.2.
0.4 multiplied by what?
0.4 multiplied by 63. Then 0.6 multiplied by 6. Plus and minus will give you what?
3.6.
So 3.6. Is it 3.6, ma? Yes, so 25.2 minus 3.6 will now give us what?
21.6.
So it means your outcome when you invest in commercial paper will be 21.6. So when you invest in bond, what will be the outcome? In bond, the outcome will be what? 0.4 multiplied by 28, 0.6 multiplied by 20, 12. 12 plus 8, 20.
20.
So that is why we don't need to show two points. You can just show it as 1 point. But if in the exam situation you show it as 2 points, no problem. You still get same results. Same results. So now, based on these outcomes, which of these is worthwhile to invest in? based on the outcome, your expected value. For shares, you have 26%. For commercial paper, 21.6%. For bonds,
Shares.
you are. So you're going to go with the
Shares.
option of shares. You're going to go with the option of shares. With the option of shares. So for you to make a decision by looking at the table will not be ideal. But in decision tree, they will want you to solve forward, then you now solve backward. You solve forward, then you solve backward. I don't know if this is clear, please.
So,
Yes,
so
sir.
please, so please, how did you get the probabilities? Because I didn't see them in the question.
Sir, they are there, sir.
Okay, okay.
Let me go back to the question, sir. Sir, see it or see them here, sir.
Oh. Thank you.
The probability will always be given, sir.
Okay. So in this case, each of the alternatives have the same the same probability for
Yeah.
the different conditions.
Yes, sir.
Okay, thank you, sir.
Let's look at, I think there should be another example. There should be another example that you will solve for me and share on the group. Another example. Let me see that.
Madam Esther, please mute yourself, please.
Sir, please, can you help me show the decision tree?
Please, I need someone to put me through. I just joined the class. So I don't know. I'm lost, totally lost.
So you have to watch the video again. I've put it on the platform that this, when you come and you say you join the class, it's sometimes you to make the class look somehow. You understand? So so I'm trying to get a question that we can attempt. Yes, that we can attempt to. Okay, let me see. I have quite a number of questions in my slide, but this is a question. But I think I've treated this in one of the videos for those that care to watch. Yes, this is another case whereby you need to solve using MPV. But before I come here, I want to present another question so that we can build on that. Let's see. It felt like I saw a question in the ICANN study pack. Okay. Okay. If I can't get a question, I can't get a question here. All right, it's no problem. So this question I'm looking at on my screen, I don't want to solve it. It's okay, let's solve it. This is a question. I believe you can see this question. That what is the name? That is Tintin PLC is considering a project involving the outlay of 300,000 naira, which it estimates will generate cash flows over its 2-year life at the probabilities shown in the following table. Now we have cash flows for projects. Now, for you to experience this cash flow, what will you do? You need to take a decision. What is that decision? Yes. What is that decision for you to experience cash flow?
To invest.
To invest how much?
300,000.
Fine.
300,000.
It means your decision node will be 300,000. Isn't it? 300,000. But what will inform you making these investments will be your expected values. Your expected values. So the point is this: if you invest 300,000 in year 1, what are the possible cash inflow that you are likely to get? I want to hear from you. What are the possible cash inflows?
100,000 times 0.25.
200,000 and 300,000.
Yes. So in year 1, you are likely to experience cash inflow of 100,000, cash inflow of 200,000, and cash inflow of what? 300,000. 300,000. Now, if you look at year 2, you can see this table is year 1, right? The first one is year 1. Now, in year 2, your 100,000 will give birth to what?
New 100,000 and 200,000.
Fine. To give birth to nil, 100,000 and 200,000. In year 2, this your 200,000 will lead to what?
100,000, 200,000, and 300,000.
300,000. In year 2, this 300,000 here will lead to what?
200,000, 300,000, and 350,000.
So, if you want to represent this on a decision tree, how will it look like? How will it look like? If you want to represent these variables on a decision tree. If you want to represent these variables on a decision tree, can you try? Can you try? Can you do something in your book?
Let's try.
In this decision tree, you have to try. Yes, it requires your own ability. Yes. So when you see it, you have to try. It was this question or this topic was tested in May 2025 SFM. Yes. Tested May 2025 SFM. And some students were saying this is their first time of seeing decision tree. I say, okay. So just know in your journey, in this ICANN journey, these will surely come your way. Yes, to definitely come your way. So can you just do something on the paper, on your book, in your book? I want to see. I want to see. So I'm waiting. Now, as you plot your tree, you must learn to label them. Label each point. It's very important. So that when you are trying to solve backward, you will not get confused. So Mr. Andrew.
Sir?
Oh, your drawing is almost set, right?
I'm trying, sir. It's 21.
Draw something, draw something. Might not be perfect, but just at least look at the table and try to come up with something. Madam Esther.
Sir?
Hope you will not tell me you are just joining this class.
No, I'm not just joining, but I don't know what to do. Why are you laughing?
I don't believe you.
I have to say the truth now before I come hit me hard.
No, it's very good. Madam Esther, are you with your book?
Yes.
Fine. In your book, draw a square. Draw a square the way we've shown. Start with a square. Yes. When you start with a square, that square, you draw a small line, straight line. That straight line, you need to make a decision. The decision is for you to invest 300,000 naira. And that 300,000 naira you're investing is an outflow. You put that 300,000 in brackets. When you invest the 300,000, there will be a chance node. That is a cycle. When you draw the line, you now draw a cycle. The cycle will have three options. Three options. One of the options will be that when you invest 300,000, you get an inflow of 100,000. The next line, you get an inflow of 200,000. The next line, you get an inflow of 300,000. That is for year one. In year two, that 100,000 will lead to other inflows, which you experience nil, you experience 100, you experience 200. So you follow that pattern. I don't like hearing, I don't know what to do. So do it and send it to the group. Let me see. Madam Faith.
I can do it, but there's no. So I can do it, but there's no light for me to do it.
Mr. Shaibu.
Sir?
On your touch, on your phone, dial your phone, on the touch.
Okay.
You can borrow Madam's own too. She understand now. You want to be a chartered accountant.
Okay.
Madam.
No.
Okay, send it to the group. Send it to the group. Let me see. Madam Taye, I can see your own. Okay. 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 This is nice.
See, you are late. You are late. You need good food. Right? You need all those junk.
Mute because of recording, please.
So, Madam Taye, I can see your work, but you didn't attach the associated probability, man. Yes, you've given me a good one. Okay, let me see, Madam Victoria. Okay, okay, yes, Madam Victoria, she has presented a very good one, though in a rush. She has done it in a rush. It's a good one. Okay, fine. Yes, Mr. Igbayi. Okay, I can see a very beautiful one. Okay, yes, this is what I want. Yes, let me talk where. This is it. 200,000 by, yes. So we have the chance node. Temitope, in year, why are you having a square in year 1? Okay, you decided to do year 1 and year 2. Is your year 1 that will lead to year 2? You get Tope?
Yes, sir.
Yes, your year 1 will lead to year 2. Let me see. Madam Odun Ayo. So I can't see the decision 3 submission. I think I'm not in the okay. Mr. Dauda. We just let
Miss Magdalene.
Okay, Magdalene. Okay.
Yes,
You are
sir.
in
Yes.
you are in business, right? You are in business. Yes, you see people in this class, I have a platform for myself, and I'm also incorporating business into the platform. So what you do, you message me after the class. Let me add you to my own personal platform likewise. So
Okay,
you see how we move. You see the tempo. Yes.
All
In
right.
business, I'm not getting the students are not responding as much. Yes, so but okay. So you just message me, let me add you to my platform. Then Mr. Ineche. Okay, I can see your work. I think I'm fine. Let me
Sir,
see.
please give me 1 minute. So
Let me see those in this class that have not. Mr. Nanju, don't tell me you are still on your way home. Mr. Nanju.
Sir, I've dropped mine. I'm at home.
Okay.
I've dropped on the PM group. Now I won't.
PM group. Okay. Mr. Babajide, I've not seen your attempt, sir.
I'm still on it, sir.
Okay. Okay, Mr. Nanju. Let's see. Okay, fine. Mr. Nanju, you've watched the video before, isn't it?
Yes, sir.
Because I can see your presentation. Your presentation shows you've watched that video.
Very well, sir.
So the way you labeled the whole thing shows that yes, I can see Madam Macaulay. So Esther, you see now you've made an attempt. Is it not better than saying you don't know what to do? This is good.
Or did I try?
You tried now.
Okay.
When you start
Thank
saying
you.
you don't know what to do, you go with that mindset to the exam hall, and that is not good. You tell yourself you can do it.
Yes, I did call my own name.
Excuse me, I got my own. Did you say anything about it?
Let me see. Let me go back to the group. Mr. Greg, isn't it? Okay. I can
It's
see.
Moshood.
Okay. All right. Let me go back to the FM platform. Mr. Moshood, where did you send your own, sir?
So that's what I'm saying. I joined late and my network has been fluctuating.
Okay.
So I didn't know what to do. I'm just following up with what others have done. Then later I will go through the video.
Yes, you go through the video. It's a price you have to pay.
Yes.
It's a
Sir,
price you have.
how about my own? Did you say anything about it?
Madam Odunayo, I mentioned your name.
I did not hear.
I said it's beautiful, man.
Okay, sir. Thank you, sir.
So, Madam Cosley, you are just joining, right? All right. So this question, what we've done is just the first step. Yes, it's just the first step. The questions that Titnin PLC is considering a project involving the outlay of 300,000 naira, which it estimates will generate cash flows over its 2-year life at the probabilities shown in the following table. Cash flows for the project year 1, for year 2, given. The company's investment criterion for this type of project is 10%. Note, all cash flows should be treated as being received at the end of the year. At the end of the year. Who can interpret this statement? At the end of the year. What is the meaning of that? So when you see it, you will not say, what is this again? What did I want you to do?
What it means is that the project lasts for a period of 1 year.
It means that, okay, it means that the inflow for year 1, the inflow for year 1 will be recorded as at the end of year 1. It means it will be recorded as at that year. But if it is as at the beginning, it means for year 1, it will be in year 0. For year 2, it will be in year 1. For year 3, it will be in year 2. For year 4, it will be in year 3. If you follow the investment appraisal discussion, you will have seen this in display when we were talking about working capital. Yes, working capital. I emphasized on this concept during that class. Based on this
What did
question,
you just say?
Ma, you answer the question. I said, when a question is asking you or telling you that cash flow should be treated at the end of the year, what is the implication, ma?
We are going to record it in that year.
Okay, so when the question is telling you that cash flow should be treated as at the beginning of the year, what will happen? For year 1, what will happen?
No idea.
No, This
It
no
will be
idea is not.
treated in year one.
It will be treated in year
Beginning
zero.
of year one.
No, in year
In
zero.
year zero. In year zero.
For year two, if it is at the beginning, it will be treated in year one. For year three, if it is at the beginning, to be treated in year two. But if the states as at the end of the year, it means year one value will be recorded in year one, year two will be recorded in year two. Do you get that?
Yes, sir. Thank you, sir.
Yes, sir.
Mr. Andrew?
Sir, I've seen a situation where they said the inflow will come in the middle of the year.
I'm with you, sir.
So how? So I was looking at that question. Now, my discounting factor, I could not solve it because of the discounting factor. When they said the inflow will come in the middle of the year.
Okay, which question is that, sir?
I think it's one of these questions you gave us.
One of the questions I gave you. Okay.
I think
On which
it's one.
topic? On which topic is that, sir?
It's on investment appraiser.
On
It's on
investment appraiser.
appraiser.
So you tag me on the question, sir. Let me know. Let me know the
Okay.
question. Yes,
Okay.
sir. So based on this question, that what is the expected value of the project NPV? This question on the screen. That what is the expected value of the project NPV? Expected value of the project. You can see how these topics can be interrelated. We are talking about risk and uncertainty. They are bringing net present value into it again. They're talking about decision tree. They are bringing NPV. It means the knowledge is cumulative. It's prerequisite. Yes, one topic is a prerequisite to another. So you cannot skip one topic and say you want to go and love one, especially for SFM. It's not possible. So now, to solve this is how your decision tree is supposed to look like. Everybody, can you see? So you can mark yourself now. You can mark yourself. You know, sometimes when I give assignments, some people will say I should mark them. If I send solution to you, you mark
Can
yourself.
you not make comments on my own?
You know, the best comment
My own.
is, you know, the best comment you should be expecting is the comment of you passing your papers.
Thank you.
Yes, that is the best comment you should hunger for. But now mark yourself based on what you've seen on the screen.
100%.
Mr. Toko, I have a question.
I have 80%.
Okay, what is the question?
So, you know, in year two, that was already solved for us. Are we the one that going to solve it in the exam, or is already solved like that? We just need to input it on the decision tree.
Yes, just input it. You input it on the decision tree. Yes.
Okay.
The values, they lead to each other. They lead. Yes. They lead to. Yes, Madam Victoria.
Yes, sir. Well done, sir. The one I sent on the platform,
Yes,
I wrote on the chance note, I wrote the value first before the probability. Is it going to be accepted in that way?
No, it's accepted, ma. It's accepted.
Okay, sir.
Yes, ma'am. So this is your decision tree. The question now is, how are we going to get our expected value of the project NPV. How are we going to get the expected value of the project PV? Now, if you look at the decision tree on the screen, you can see it is well labeled A, B, C, D, E, F, G, H, I, J, K, L, right? M, N. Fine. Please, everybody with your book. For us to calculate NPV for each node, what are we going to do? NPV for each node, what are we going to do? In your book, write node A. In your book, write node A. I have the solutions already in my slide. I actually don't want to solve this question because I've solved it before. So please, in your book, node A, we need to get the NPV for node A. Looking at this decision tree, what are the lines that lead you to node A? First, you have your year zero, isn't it? Your year zero will be constant for every point. Your year zero, as at year zero, you are giving out an outflow. You are investing. In year one, you have an inflow, right? Isn't it? Of 100. In year two, based on node A, what is the figure in year two? Based on node A.
Zero.
Fine. That is what I want to get. Zero.
Nil.
Yes, nil. Yes. Now, if you have these variables, and the question is telling you that your discounting factor is what? From the question. That's the 10%. So based on these variables, everybody, can you determine the NPV for node A? Can you determine the NPV for node A? Please solve it, irrespective of what you are seeing on the screen. Solve it yourself. Yes, Madam Macaulay.
Please, I didn't get your explanation, sir. For node A.
All right. So, Ma, if you look at this diagram, you invest 300,000 at year zero, right? Madam Macaulay, are you there? Hello?
I think the network throw her out. Too.
Okay. But let me re-emphasize again for others that might not be on the same page with us. In year zero, you invested 300,000. Your investment is bringing back how much in year one? See it,
100,000.
Your year one value leads to year two. It's bringing back how much in year two based on node A? Zero. Nil. Now, if you want to get your NPV based on node A, what will you do? You have it, your year, your cash flow, your discounted factor, then your present value. So in year zero, there'll be an outlay, right? An outflow of 300,000. Your discount factor in year zero will be what?
To be one.
Very good.
One.
To be one.
One.
To be one. Everybody should know that.
Sorry, Mr. Tokwe.
Yes, sir.
Sorry, in note A,
Yes,
in
sir.
year 2, why are we having nil here? I don't understand, sir.
Yes, based on the data given to us in the question, sir. It is nil, sir. Let's go back to the question. Sir, see it. 100. That leads to year 2. Can you see it?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. I've seen it, sir.
So, class, if you should solve for your MPV for node A, what will be your result? I want to know those that have solved it.
29100.
200.
Negative.
Negative.
100.
Negative.
Fine, negative. You see now, I'm very happy tonight. So I can go on and on. Yes. So for B, for node B, what will be your MPV? Your cash flow for year 0 is still 300. Still 300. When you trace the lines that lead to B, you still have what? Your 100. Your 100 leads to what? 100. Isn't it? So when you substitute this value and look for your present value and determine your MPV, what will be the outcome? 300 leads to 100, 100 leads to 100 for B. Determine your MPV for node B.
MPV is negative 126,500.
Fine. Negative 126,500. Before I move further, somebody is in this class. You don't know what we are doing. Speak out. Based on this question we are solving.
I don't really understand very well. I'm sitting there.
Same here. Me, I'm still at
So
work.
that's
It's really distracting
minus
me.
126,500.
That's why I'm keeping silent and see. Like,
I had issues with my network, so it's just.
I can hear everybody. Okay. The whole thing is like magic.
Hello, sir. The decision tree is very clear, sir, according to me here. But how to place it on and work on MPB is the area that I'm not getting it clear.
All right. Fine. Okay. And Amakoli, your hand is up. What is the issue, man? Okay. Let's see how to go about this now.
Sir, sorry, I'm having issue with my network here. So you were asking question that anybody that do not understand to let you know. That's why I raised up my hand.
So tell me what is it that you don't understand now?
You know, when you were asking me question, when I was asking you question, you started explaining and I was logged out.
At what
So
point?
you said that anybody that do not know how to get the MPV should let you know. So me, I believe it is the expected value from A, J, and M that is going to give us the NPV, Abi.
For each of the node, for node A, this A, ma.
Yes, sir.
What will be your MPV for A?
Okay.
in year 0, you invested 300, right?
Yes, yes.
This 300 results in an inflow of how much? 100
100.
in year 1. Your year 1 leads to year 2
Yes.
with corresponding inflow of nil. So
Yes.
bringing all these variables into your table where you have year 1, year 0, year 1, year 2, and your cash flow. You have outflow of 300, inflow of 100 with a discount factor of 10%. What will be your present value?
Thank you, sir. Thank you, sir. I'm okay. Thank you, sir.
I want to, for those that say they don't understand, I actually want to know how to help. How to help. Yes. Madam Ura, is it Ura? You've been in this class from the beginning. URA.
Yes, sir, partially. I'm still at work, so I'm in and out. I'm the one that said everything is looking like magic.
Okay, you are still at work, ma'am.
Yes, sir.
And it shows you are not paying full attention, right?
Yes, sir. That's the main problem.
Okay, ma, your own is not an issue. You understand?
Okay, sir.
The point is this. You have to watch the video again. You understand?
I will, sir.
So when you watch the video again and you don't understand, please reach out to me.
I will.
Yes.
I will, sir. Thank you, sir.
Yes, because you know you cannot, two things cannot occupy a space at the same time. Yes.
Very difficult.
Yes, that is science for you. It's either you give it to this or you give it to the other. Yes. So the understanding will not come as you expect, man. Yes. So just keep following. Watch the video again. Then I will expect feedback. Are you on business?
No, sir.
Okay. What is your name on the platform?
Blessing.
Okay. All right.
Blessing, I was the one that chatted you. We had some personal conversation some days ago.
Okay. All right.
I'll chat you personally again.
All right. No problem.
All right, sir.
So who else? Madam Costly, yours. You see, there's always a vibration. So let me allow you to speak.
I said I understand it to a point. I'm still studying the diagram.
All right, thank you. Your own is not a problem, likewise. Madam Comfort.
I don't understand it, though. Maybe I should try going watch the video again and see, but I don't understand it at all.
Okay, you didn't, and you followed from beginning, man.
Hello, sir.
Sorry, 1 minute, sir. Let me conclude with her. Madam Comfort, did you follow from beginning?
No, I joined 45 minutes into the class. I didn't see when you posted the time, so I joined like to 7 or so.
Okay. Madam Comfort, you do me a favor. You watch the video again. I'll follow up.
Yes, I will.
Right, fine.
I'll do that. Thank you.
Alhaji Isa.
My Oga, sir.
Yes, sir. What is the issue, sir?
Well, no, sir, what I'm trying to get it out now from the decision tree here is that we have 2 years. If we are to work on the MPV, we have 2 years.
Yes, sir.
Then are we going to work MPV for every A to I that we are having here?
Very well, sir.
For two years.
Yes, sir.
Okay. Okay,
You work
sir.
NPV.
Okay,
You
sir.
work
The
NPV.
second question, please.
Yes, sir.
When we are working the MPV, how do we make use of the probability figures that we have here?
We'll come to that point, sir.
No point for that.
I said we'll come to that point, sir, when we will use the
Okay,
probability.
sir. Okay, sir.
Yes, sir.
Okay, sir.
So
Thank you, sir.
for node B, the MPV is what? A negative value, right?
Yes.
Minus
126.
126,500.
Yes. So in case you are not getting the values right, this is the value for node B. For node B. Then for C, the MPV will be what?
Minus 43,900.
Minus 43,900. Can you see it? You can see the value. Then the
Excuse
next
me,
is,
why is it minus 43?
sir, when you say,
Why is it minus? Because not 90,900 plus 165,200 is not up to 300 now. Then when you less it, I think it have to be positive of a 43 now. Why minus? That's why.
sir, this 300, what is it positive or negative, sir?
It's negative. That is inflow.
Is outflow negative?
I mean outflow. Sorry, sir.
So is your
That's initial
outflow
capital.
is your outflow less than your inflow or greater than your inflow? So in your calculator, press minus 300 plus 9,900 plus 165,200 and tell me the outcome, sir.
Minus 300, right?
Yes.
Plus 9,900 plus 165,200 equals minus minus 43,900, sir.
Hope that is clear, sir.
Okay, so in case of exam, so if we want to solve it, we first of all start with minus 300 or minus any figure as outflow.
No. The outflow is negative. Do you understand, sir?
Yes. Yeah.
And that is why it is in brackets, in jackets. Do you understand?
Okay.
So
Yes, sir.
if your negative value is greater than your positive value, your actual results will be negative. If your positive value is greater than your negative value, your actual outcome will be not positive. I don't know if you get
Okay,
that.
sir. Thank you, sir.
So for node D, the outcome will be what, please?
Minus 35,600.
Yes, minus 45,600. And for node E,
47,000.
47,000. Please, what is the question?
Sir, sorry, I've been hearing you say add a special group. I'm not added to the group yet.
Please, there is no any special group. Those I'm talking to, they understand there is no any special group.
Okay, sir.
The node F, what is your outcome?
Sir, please check that calculation again. Before. Sir, please, sorry. Check that calculation again. That one you had minus 43. I had minus 44,800.
It's correct. Minus 43,900.
It's correct. That's
Okay.
3,900.
Okay. Okay.
So node F, it will be what?
I'm on YouTube.
129,600.
129,600. And for G, it will be what? For G, please make sure you are writing, because you need these results for the next stage so that you not get confused again. You need this result for the next stage.
137,900.
137,900. That is for node G.
Yes, sir.
Then for H is what? For H,
Sir, you're not showing the decision tree again.
we left that point, ma. We are looking at the MPV. So this is decision tree anyway. If you want to see it.
No, let me go back to my note. Don't. I will do it from my note.
So for H, the result is what?
220,500.
And for I, if you get the value for I, tell me, then we'll move to we'll determine the next stage now.
$261,800.
261,800.
Sir, please, what is your G?
It's 261,800.
Oh, G.
The G is 137,900.
Okay, sir.
Yes, ma. What is your question, ma?
Please, sir, let's check that G again. It's like it's 129,600.
Please,
I'm not
somebody
sure.
should check very fast.
It's 137,900. I just saw now.
So the G is 137,900. All the figures given are correct. Now, let's come back to our decision tree. Now, what leads to A, B, C? What leads to A, B, and C? Is this chance J, right?
Yes.
Isn't it? Now, what will be your expected net present value based on this point, J? What will be your expected net present value? With the word expected, you know there will be a combination of two things, isn't it? Your probability, probability, and what? Your MPV.
MPV.
So Mr. Isa that is asking me when we are going to use probability, this is the point.
Okay, sir.
So now, for you to get your expected net present value for A, what will you do? Your MPV for A is what? 209
100.
multiplied by what? 0.25.
$52,375.
275, right?
Yes, sir.
52,275.
Okay.
Now, what will be your expected net present value for B? Your MPV is 126,500 multiplied by 0.5.
63,250.
Fine, 63,250. Negative, yes. For C, it will be what? Your MPV, 43,900 multiplied by 0.25.
10,975 negative.
So what will be your combined NPV based on these three? It means the addition of your results. You get the addition of 52,275. It will give you a negative result. Let's see it from the slide.
Negative 126,500.
Fine, negative 126,500. So can you see it? Can you see it?
Okay.
Now, the next, from your decision tree, go back to your decision tree. When you go back to your decision tree, what is the next combination?
Okay. DEF.
DEF to determine K. Yes,
Yes.
K to determine K. So your MPV for D is what?
45,600.
Yes, 35,600 multiplied by probability 0.25.
8,900.
Yes, 8,900. So for E, it will be what? 0.5 multiplied by the MPV of 47,000.
23,500.
23,500. Positive. Positive. Then for F, it will be what? 129,600 multiplied by 0.25.
32,400.
32,400. So you can see it. Combine NPV of the nodes D, E, and F. You have it as what? 47,000. So the next point of attraction is what? Is GHI, right?
I is what?
GHI. For us to get L, not L.
That's L.
Not L. So what will be the outcome? The MPV for G is what? 137,900 multiplied by 0.25.
34,475.
4,475.
34,475. For H, it will be what? For H,
Please, who can give us the
250.
you should have 110, 250.
Yes, sir.
Then for I, it will be what? 261,800 multiplied by 0.25.
65,450. By what? Sorry. 265.
That is 261,800 multiplied by 0.25.
65,450.
Yeah, 65,450. So the summation should give us a positive result.
210,175.
Combine MPV of nodes 44. Or what do we have?
210,175.
210,175. Fine. Fine. Let's go back to the decision tree. Now, the combined NPV for J, what is the outcome for J here? Negative 126,500, right?
Yes, sir.
That is the result for J. For E or for K is what?
47,000.
47,000. For L is what?
210,175.
What will be the next thing? The associated probability in relation to L is what? 0.25. So you get your combined expected net present value for node J, K, and L. For node J, K, and L. So it means your result of J, which is 126,500, multiplied by the probability here, we give you what? Your expected
negative 31,625.
Fine, negative 31,625. For K, your outcome is 47,000 in relation to this 0.50.
23,500.
23,500. 23,500. Now, for L, your result was what? 210,175 in relation to the probability.
52,544.
52,544. when you add everything, you should get to the point of M, right?
Yes.
When you add your whole result, you get to M.
Yes.
Yes, sir.
So when you add, what will be your results?
44,419.
So 44,419. What would be your advice? Since I'm investing 300,000, and based on NPV, I'm getting a positive result. What should be the advice? The expected net present value of the project is what?
44,419.
44,419.
So it means it is worthwhile investing.
Yes.
Because we have a positive
value.
Results, value, yes. So now, let me go back to the question. What is the expected value of the project NPV? That is what you determined. Now, the question is asking us in the B part, what is the probability that the NPV of the project will be negative?
It will be the ABC.
Okay,
A,
B, C, D.
Okay, A, B, C, D. Yes, that's the probability that the NPV of the project will be negative. So what you do, you see those probability, those probabilities for each of the year. The probability for 0.25. For year 2 is 0.25. When you multiply both, you have what? The combined probability will be what? The question is specific, that what will be the probability?
0.065.
0.065. So in percentage, the probability that the NPV will be negative will be what? 6.25%. That is for project, for A, for not A. The probability for year 1 and year 2 multiply, you have the combined probability that the result will be negative. For not B, you do same. What is the probability? The question is specific. What is the probability? So the probability will be what? 0. What?
25.
Multiplied by what? 0.5.
0.1250.
0.1.
So in terms of percentage, it will be what?
12.5.
12.5.
12.5. So for C, you do same. For D, you do same. Those are the, why are we using those values? They are the values that we have negative NPV. So you can see them here. So you can see.
Edison.
Yes, sir.
Okay, so now, I just want to ask. I want to ask from a layman's perspective, and from the point of view of being inquisitive. So now, instead of should I say, why did we have to multiply those probabilities and not add them up?
Another what, sir?
Add them up.
Okay. Yes. We are not just we are not adding them, because for us to know the multiplier effect in terms of the negative results, and based on the theory of probability, we need to determine what will be the effect of each chance in the decision tree resulting into negative value. So we are not adding them because we don't want to determine the additive effect. We want to see what will be the multiplicative effect of having the negative results, in terms of probability. So we are not adding them because we want to determine what will be the magnitude in terms of having two events or two chances in a particular line of action, but the result is not favorable. So the probability is not to be added, but to be multiplied against each other to determine their combined effect. So when we talk about joint probability, in joint probability, we do what we call probability of A multiplied by probability of B. That's it. When you go back to, you're making me to go back to my secondary school days now. When we do probability that two events occur, we can express it as probability into the bracket of A in relation to B. So because these scenarios are independent scenarios, you understand? So we can say probability is of A in relation to probability of B. That is, you multiply. That is joint probability, sir. The rule is that the two events occur together. So when two events occur together, you multiply. So because they are linked, sir, they are linked. So the rule is we multiply. So if we are to go back to our elementary probability, when we have combined probability, it means that two or more events occurring together or in relation to each other. It means that what is the probability that A and B happen together? Yes. And what is the probability that A or B happens? So when we have combined probability, we multiply and not add. So the probability that A and B occur, the probability of B given that A has occurred, and so on and so forth. So we add. We multiply rather, sorry. My system is going.
Hello, sir. Please,
yes.
can you show slide 26? I want to quickly.
I'll forward the slide.
Okay. All right.
I need to end the call before my system goes.
Yes,
totally
sir,
down.
so that we can get the slide, sir.
I'll forward the slide. My plan is to treat simulation too. But I will spare 1 hour tomorrow if you'll be available. Let's talk about simulation. It's very important. So by 6 tomorrow, I will be available for simulation. Yes.
Okay.
Then on Saturday, for those offering PM, on Saturday morning, we'll add more to our class by 8 in the morning. We need to cover up and be free by April ending at most. So you see more of me day by day, and in order for us to cover up. Yes. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you.